Hello, my fellow chemists. In this video, we're going to take a look at conversions again between the English and metric system, but we're going to take a look at some more advanced problems. And the reason that this is labeled as an advanced video is because it does assume that you have a basic understanding of dimensional analysis and the factor label method, and also some knowledge of conversion between the metric system and conversion between the English system, and then how to convert between the two systems. So if you find that you need a brush up on any of those skills, I'll put a link up in the upper right hand corner for you. So in this video, we're going to take a look at some word problems and how to go about solving word problems that are 4 or more steps in length. So these would be the more challenging conversion problems. So let's get into it and take a look at the first problem. As always, or as with the last video, I have our English to English conversions up here. I have or our English to metric conversions up here, our English to English conversions over here, and then at the bottom I have our metric to metric conversions so that we can kind of use those as a reference. And again, for whatever course you're taking, make sure you find out from your professor what information he will be giving you and what he expects you to memorize. But for this video, I'm going to assume that all the conversions are being given to you and you just need to know how to use them. So let's take a look at this first problem. It says Bill is 52 years old and weighs 180 pounds. If he gains 2 pounds per year, how many hectograms will he weigh when he is 55? All right, so first thing you want to do on a problem like this is kind of sketch out what you're going to do and what you need to find. So ultimately, we need to find hectograms, okay, and that is a metric unit. Um, And then what we need to do is we need to go from 180 pounds, uh, which is an English unit. And the first step is to find out total pounds. How much he gained. And that's still going to then be in an English unit. So now once we find out what his total weight is, because he had several years to gain weight and he gained 2 pounds per year, we'll know his total weight in pounds. And then we need to convert pounds into hectograms. Well, pounds is an English unit, and hectograms is a metric unit. So if we took, and they're both mass units, so if we take a look on masses, we can go from pounds to kilograms to convert from one system to the other. So the first thing that we're going to do is we're going to convert his pounds into kilograms, and that'll get us into the metric system. And then we're going to go from kilograms down to the base unit of grams, and then we'll go from grams up to hectograms. So we'll go from kilograms to grams, and then grams to hectograms. So we're going to be looking at a total of 1, 2, 3, 4 steps that we're going to be using to solve this problem. And the conversions that we're going to be using is pounds to kilograms. So I'll circle that one up there. And then we're going to be going from kilograms to grams. Okay, so we'll be doing that. And then we'll be going from grams to hectograms. So those are the conversion factors that we're going to use, and these are the steps that we're going to use to solve the problem. So the first step that we have to take a look at here is he's 180 pounds. What's his total weight after a couple of years of gaining 2 pounds per year? Well, anytime you see something in a word problem that says one unit per some other unit, like we have here, 2 pounds per year, that just kind of can mean that per, you can use that as a divided by. So it's 2 pounds divided by 1 year. And you can actually use that as a conversion factor between pounds and years. So that is an important piece of information. And you see in the first part of the problem, we're going to use that to find his total weight. So the first thing that we want to do is realize he's 55 years old. Put a Y there for years. Um, and or he's going to be 55, and he's initially 52 years old. So if we find out how many years went by, it's going to be 3 years. Okay, so he started out at 52 and he ended up at 55. So 55 minus 52 means there's 3 years that are going by in which he's gaining weight. Now we can use this 2.2 pounds per year to convert back and forth between years and pounds. So let's see how we're going to do that. We have 3 years that he's been gaining weight, and this is going to be our conversion factor. We're going to use that 2 pounds per year as a conversion factor. We're going to put years on the bottom so it'll cancel out. And we'll put pounds up here. And it says that he gains 2 pounds per 1 year. So for every 1 year, he gains 2 pounds. All right, so now this little miniature problem is set up so that years and years cancels out. And it's just like a regular factor label problem. Multiply across and divide up. And what we'll find is that in 3 years, he's going to gain 3 times 2 divided by 1. He's going to gain 6 pounds. So this is gained. So he gained 6 pounds. And the problem tells us that he started off at 180 pounds. So this is what he started at. And then he gained 6 pounds. So that means he's going to be at 186 pounds when he is 55 years old. That's the first part of the problem, finding his total pounds, what he's going to be at 55 years old. So we did the first step in the problem. We found out how much he's going to weigh when he's 55 years old. Now, the next steps in the problem are going to be converting his total pounds of 186 pounds into kilograms, then into grams, and then into hectograms. So let's do the next step. He's 186 pounds. We'll draw our conversion line because we're going to go from pounds to kilograms. That's our second step. Pounds on the bottom, kilograms up at the top. And we can see that our conversion factor is 2.2 pounds for every 1 kilogram. 2.2 pounds for 1 kilogram. And pounds will now cancel out. And we'll multiply across and divide up. So now when we convert his mass from pounds into kilograms, we get 84.5 kilograms. All right, so that's the second step of the problem done. We converted into kilograms. Now we have to go from kilograms into grams. Okay, so we'll do that here. We'll draw our conversion line here. We'll put kilograms on the bottom because that's what's going to cancel out. Put grams on the top because that's what we want to get to. And we can see the conversion here that kilo is the bigger one. Kilo is higher up on the scale than grams. So the kilo is the big one, so we put a 1 for kilo. And then for grams, we can see that it's a kilo is 1,000, grams is 1, so it's 1,000 to 1 ratio. So there's 1,000 grams for every 1 kilogram. Kilograms and kilograms cancel out. We again multiply across and divide up. And when we do that, 84.5 times 1,000 and then divided by 1, we get 84,500 grams. We're still not done, but that's the step going from kilograms to grams. Now we have our fourth and final step left, going from grams to hectograms. So we have 84,500 grams. And now let's do our final conversion from grams to hectograms. Put grams on the bottom because I want that to cancel out. Hectograms on the top. And we can see that hecto and gram is a relationship of 100 to 1. Hecto is higher up on the chart, so it's larger, so that's the one that gets the 1. That's the big one. And the grams is the smaller one, so that'll get the 100. So now it's all set up so that grams and grams will cancel out. We now just multiply across and divide up. So if we take 84,500 times 1 and then divide by 100, we get 845 hectograms. And that is the final solution to the problem. So you can see this is a little bit more of an advanced problem because it is 4 steps long to get to the answer here. So finish the last step there. Now, the next problem that we look at is actually going to be, I believe it's something like 7 steps long. So take a deep breath, close your eyes and relax for a minute and kind of get ready. And we'll take a look at the next problem. And if you can do this next problem, this would be considered on pretty much any exam. This would be considered a hard problem because there are so many steps and conversions, and you'll be able to see why in this type of problem, why the factor label method is so powerful. It's because it lets you know when you're supposed to multiply, what you're supposed to multiply by, what you're supposed to divide by, and lets you keep track of all your units for larger problems where it's easy to kind of lose track of them. So let's take a look at this second problem here. All right, so this problem here says if John walks 3.2 miles per hour, how many minutes will it take him to walk 2,000 meters? All right, well, let's take a look at the information that we're being given in the problem. Well, it's 3.2 miles per 1 hour. We can use that as a conversion factor to convert back and forth between miles and hours. And we see that he goes 2,000 meters. And what it wants us to find out is minutes. All right, well, geez, how do you go from there? So what you're given is these 2 pieces of information here. And from these 2 pieces of information, you have to find how many minutes it takes him to walk 2,000 meters. Well, the first thing that you want to notice is meters is a length unit and miles is a length unit. So if we can convert 2,000 meters into miles, we can then have the miles and miles cancel out and we'll be left with time. So that time that we'll be left with will tell us how much time it takes him in hours to walk 2,000 meters. Then we just have to convert the hours into minutes to solve the problem. So our first step is going to be converting these 2,000 meters into miles so that we can then use this 3.2 miles per hour as a conversion factor to cancel out units. So let's begin by converting 2,000 meters into miles. So if we have 2,000 meters, and the conversion factor for length is 1 inch is equal to 2.54 centimeters. So we need to first go from meters to centimeters. So that's going to be our first step. So we have our base unit here in meters, and we want to go into centimeters down here. So that will be first step, and we can see that's a 100 to 1 ratio there. And so we'll have 2,000 meters that we're starting with meters, and that is a metric unit. And then we're going to be converting meters into centimeters, which is another metric unit. And then once we get to centimeters, now we can use that in our English to metric length conversion up here. So that'll be our next step. So we'll go centimeters to inches. So then we'll go centimeters to inches over here. And now we're in the English system once we get to inches. And then once we get to inches, we need to go from inches all the way up to miles. So we're going to use all of these conversion factors in here. So we'll go from inches to feet. It's still in English. Then we'll go from feet to yards. And we'll go from yards then to miles. And English and English. And then once we know how many miles that he traveled, then we can use that to convert into hours using this conversion factor up here. And then we'll convert from hours into minutes. So you can see that this is actually going to be a 1, 2, 3, 4, 5, 6, 7 step problem. And the first step is to convert from meters into centimeters. So we have 2,000 meters. We'll set up our conversion. Meters will go on the bottom, centimeters on the top. And we can see down here, meters is the larger unit, so that'll be the 1. And the centimeter is the smaller unit, so that'll be the 100. We're set up so that meters and meters cancels out. We then multiply across and divide up. So when we do our first step, we end up with 200,000 centimeters. So our first step is done. Now we need to go from centimeters to inches, and that will be with this English to metric conversion up here. Centimeters on the bottom because we want it to cancel out, and inches on the top. 2.54 centimeters for every 1 inch. Centimeters and centimeters will cancel. Multiply across and divide up. And when we do that, we take 200,000 times 1 divided by 2.54. We will end up with 78,740 inches. Okay, so now that is the next step done. Now we need to go from inches to feet, and that's going to be using our English to English conversion over here. So I'll draw our conversion factor line there. Inches on the bottom because we want it to cancel out. We want to end up with feet, so we put it up there. There are 12 inches for every 1 foot. So it's set up so inches and inches will cancel out. We multiply across and divide up. And when we do that, we find that we have 78,740 times 1 divided by 12 gives us 6,562 feet. Okay, so now we've gotten to feet. Now we need to go from feet to yards. So that'll be our next conversion. Feet will go on the bottom. Yards will go on the top. And from our English to English conversions, we can see it's 3 feet for every 1 yard. 3 feet for every 1 yard. We're set up so that feet and feet cancel out. We'll multiply across and divide up. And when we do that, if we take 6,562 times 1 and then divide it by 3, we get 2,187 yards. So 2,187 yards. All right, well, that was our fourth step. Now we need to go from yards to miles. Again, we'll use our conversion factor that we have up here, our English to English conversion. Put yard on the bottom, mile on the top. For every 1 mile, there's 1,760 yards. So we're set up so that yards and yards cancels out. We'll multiply across and divide up. And hopefully you can start to see now, once you have everything mapped out and you know what you're supposed to do, like we did here, it does make the problem much easier. Now it's just going through each of the steps and solving for them. So we take 2,187 yards and we multiply it by 1 and then divide by 1,760 yards. And that'll give us 1.24 miles. So 1.24 miles is if we convert 2,000 meters into miles. So that's how long he walked. Now we're going to use this conversion up here, 3.2 miles per hour, to convert his length into a time. All right, so we got into miles. Now we need to convert miles into hours. And that's going to be using this conversion up here. Put miles on the bottom because we want it to cancel out. Hours on the top because that's what we want to end up with. So in 1 hour, he goes 3.2 miles. Remember, this was given in the problem, 3.2 miles per hour. So that's where we got that conversion factor from. And we have it set up so that miles and miles will cancel out. Multiply across and divide up. And when we take 1.24 times 1, you get 1.24. And then when you divide by 3.2, we get 0.388 hours. 0.388 hours. Now, our last step, we just converted from miles into hours. Our last step is to convert from hours into minutes. So this will be our last conversion factor. Put hours on the bottom. That's what we want to cancel out. End up with minutes on the top. That's what we want to get to. And for every 1 hour, there are 60 minutes. So now we're set up so that hours and hours will cancel. We'll multiply across and then divide going up. And when we take 0.388 hours times 60 and then divide it by 1, we get 23.3 minutes. So it will take him to travel 2,000 meters, it will take him 23.3 minutes. So you can see with these larger, more complicated problems that using the factor label method and keeping all your units straight is very important. This helps you know when you're supposed to multiply, when to divide, and make sure that you end up with the units that you're supposed to end up with. All right, well, that's it for this video. These were two more challenging word problems to solve. I hope you learned something, and I'll see you guys in the next video.